amazed to see so many people here because it's the last morning, and you know I'm going to talk about unit testing, right? Thank you, and thank you especially to the nice man in the front who has rescued my slide deck from the ether. Let's all give him a little, Okay, cool. All right, let's get going. So I want to introduce you to my app. So it's called Show and Hide, and it's an image processing app. So this is V1, so the UI is pretty simple. So I think it's a reasonable example for us to work with today. So briefly, what the app does is it detects the dominant color in an image, and it creates these like cool, partially colored images. So think of those postcards of London where, you know, it's black and white and the bus is red. So the idea is that, you know, you can do that, but it's like algorithmic, so you don't need, you know, artistic talent. So I have a work chart that's kind of built around these concepts that goes into a lot of them in more detail. So we're going to do this like, consider this as the highlights wheel. Because what I find useful about conferences and events like this is finding out what people really do, right? So I'm going to talk to you about what I really do, not, you know, what I might do in a constraint-free world in a contrived example, or if I could bend my spec to illustrate what I was going to demonstrate. This is like what I really do. But admittedly, I'm a little bit of a unit testing obsessive, which, you know, you will discover. I'll take you on a journey. So I want to start with some things that I think are true. If you find these assumptions wildly disagreeable, you're probably going to hate my talk. There's some other great ones going on right now, so you could probably still catch them. So the first is that there's no one true way of writing software. I don't have a lot of, you know, let's say I don't have any patience for these arguments of like, which is better, Vim or Emacs? You know, at a higher level than that, you know, I think we work with the constraints that we have and the information that we have, and then we make the decisions that make sense at the time. So I'm just going to propose a contentious theory. Maybe the last developer wasn't an idiot. Maybe they were working under different constraints with different information. And the second is that you're not your code. And we use that as a reason not to get too attached to our code, right? To say, be okay if it gets deleted. But I also think of it like there's the flip side of that, which says we all write stupid code sometimes. It doesn't mean that we're stupid. And the third thing, I'm going to get really contentious now. Any test is better than no test. So I've been on those code reviews where someone's like, wow, you know, if you refactored everything, you could write a much better test right here on this very small thing. And I tend to take the approach of like, you know, write a test, even if it's a bad test, because at least then you'll have a test. And then you can improve it, and you can improve your code. And so this is mostly about avoiding this kind of analysis paralysis that Daniel talked about yesterday, right? So instead of agonizing over perfection, I'm like, you write a test, you go from there. Okay. Now I'm going to tell you some stories. Who actually writes tests, unit tests for their iOS apps? Oh my God, so many of you, I found my people. It's all right, you gave me internet, so you're still my friend. So guess what kind of coverage the first iOS app I worked on had? Any numbers? 0. I'm going to give you a clue. I used to work for Google. 1. Yeah, I admire your optimism there. You were right the first time. We had 0 test coverage. We shipped without unit tests. And so at the time, I was a junior developer, right? But I knew that this was wrong. So, you know, I said to our tech lead, I'm like, you know, shouldn't we like, you know, write some tests? And he said, we're moving too fast to write tests. Now, there were so many problems with this statement, not least of which is that we weren't actually moving that fast. But, you know, and so his answer was really not compelling to me, but I really wasn't in a position to argue. But, you know, it's okay, because in the way of all badly executed projects in remote offices, in the fullness of time, this project was taken to the US, and I went to work on something else. And so now, very exciting, we had some tests. Not many tests, right? We talked a lot about designing for testability and like dependency injection and all that stuff, but we didn't actually, like write that many tests. So again, in the fullness of time, who knows the answer to this story? This project too was taken to America. I was living in Canada at the time. And so I did what anyone would do in this situation. I moved to Australia. And so now I was the tech lead, and I had 2 engineers, I had a clear mandate, and I had this 3-month deadline. And so have you noticed how often in this industry we learn what not to do? Yeah, it doesn't always teach us that much about what we should be doing. But, I'd learned that it was a bad idea to ship without unit tests. So we had a test target. And we also had this deadline that was pretty tight, right? So about 2 months into the project, and I'd finally started to believe, yes, we may make this deadline. We might just send the app to the App Store in another month. And my manager calls me into a meeting and tells me that his manager isn't happy with our test coverage. And like, my mind is blown, right? Because when I was working on this app without unit tests, no one seemed to worry about it, right? And like, we've tested our model code. We're just about to add some automation tests. Like, what more does he want? Doesn't he know that iOS is fundamentally untestable? Anyway, I'm going to finish that story later, but I think we can talk a little bit about how we can do better than that and how iOS is not fundamentally untestable. So a little bit of background. I want everyone to be happy with these things. So just a couple of testing concepts that I'm going to use throughout. So it's important that you're happy with them. And so the first is mocking. Who uses mocks? Cool, my people. I'm so happy to find you all. I've given this talk and people are like, what? So mocks are these objects that we can use in tests to simulate the behavior of a real object, right? So we can give them set responses for events. We can record all the interactions with the mock. And so we have nice mocks and we have strict mocks. So you may guess that nice mocks are nicer. So strict mocks have to have absolutely everything defined, whereas nice mocks, they'll give you a little leeway with which to hang yourself, So there's a bunch of different mocking frameworks available. I tend to use OCMock, but there's also OCMockito. And it's worth talking about when we use mocks and why. So we use mocks to verify interactions, and we use mocks to create state. So for example, in an image app, right, of course we're going to have, we're going to use the camera. And so some devices have cameras and some devices don't have cameras. And so how do we want to create that state of, in this test, the device has a camera. In this test, this device doesn't have a camera. And the way that we do that is using mocks. And this is why, we don't mock data structures, right? Use an NS array instead of a mock NS array, because trying to mock the state of an array is way, way harder than just using a real array, right? And so I think of this as inductive proofs. Has anyone done inductive proofs? Yes, there's one person. Yeah, so, when we do inductive proofs, and it's just math, right? But there's just things that we accept as true because we can't prove everything. So we accept that 1 and 1 is true, is 2, right? And so when we're testing, I think our inductive proof is that we have to accept that our data structures work because they're supposed to, especially the ones provided to us by Apple, right? And so, when we verify interactions, these tests are much more tightly coupled to the behavior of our code, right? And sometimes this is totally what you expect. It's just something to be aware of. And now I'm going to show you something more exciting, because, I know that not everyone is excited about mocks. Okay, let's go, Kif. Let's go. Okay, so these are my UI automation tests running. So I could have made a video, but I'm very brave / a little bit stupid, so, they're running live from Xcode. So these are known as monkey tests, right? So there's something that will go through and tap the buttons on your app, and they'll make things happen. And so these are the properly black box tests, right? They don't know anything about your code. They just use the UI. And so I'm using Kif here, because it wraps your Apple's UI automation, but it doesn't matter. None of the details matter. The point is that we're writing tests, right? And so these are not unit tests, but I mention them because like when it talks about unit testing UI code, I think this is a very complementary strategy to it. So this is our like arc of the whole app. Does everything work together? And our unit test the details. I also find them very soothing to watch.
Yes.
Okay, it's happy. That's good. All right, so final thing, I promise, before we start talking about like actually unit testing. I want to talk about coverage. So I use cover story. There's other options, franking cover, xcover, but code coverage tells us what percentage of our code is covered. And then we can use it to say, look for places with not great coverage so that we can improve them. But coverage just means that a line of code has been executed, right? It does not mean that it worked, right? So you can write one enormous test that executes every line of code in your app, and it may really not tell you anything other than it compiles. And I'm sure we've encountered apps that are not meeting that low bar, but you know, it's not necessarily helpful information. And confidence is about knowing how things work and having our different inputs covered. So confidence is what allows you to develop against your tests. And so you can think of it this way, is that confidence implies coverage, but coverage doesn't imply confidence. Okay, let's talk about view controllers. There's a talk after this, and someone's talking about how view controllers are terrible. I'm pretty excited about that. But you know, the big reason that we don't find it that easy to test our iOS apps is because the view controller mixes our control code and our view code together. And if we want to write tests, we have to start creating seams between things, right? Because we really don't want our view code and our control code entwined too much. It makes it very hard to test. So what we do when we create a seam is that we isolate parts of it, and so then we can write tests around it. So the name presenter comes from this concept of the MVP or model view presenter pattern, but like whatever, doesn't matter. Point is we got some code out of that view controller and we put it in something we called a presenter, right? And so if we wanted to take some control code out of our view controller, what kind of things might we take out? Suggestions? No? Yes. Yes. Delegates, selectors that we put on buttons, network calls, interfacing with the model, that kind of stuff. So then, you know, each view controller has a corresponding presenter, you know, and you have to deal with your memory management here, right? So obviously the presenter needs a weak reference to the view controller, and the view controller needs a weak reference to the presenter. In every other respect, though, I think of it as the presenter is the boss of the view controller, right? So then, you know, I use a top-level class to abstract away some common things, and the main one of that is calling presenter view loaded and view controller view did load. So at that point, the view controller loads the view, makes everything look nice, and then the presenter comes in and puts the data in, makes the network calls, adds the selectors. So, you know, I find that the best possible level of separation in this model is that my top-level view controller knows that there's a top-level presenter. My MyScreen view controller knows that there is a presenter. And my MyScreen presenter knows that there's a MyScreen view controller. And I also use this, I find this pattern really helpful when I'm doing reusable views. So for example, in an app I'm working on right now, we have a bunch of different ways to send messages, and they all have different presenters in the same view controller. So it's really similar to the reactive Cocoa MMVP pattern, but like you don't have to go full on reactive Cocoa to make it work. Like I just write a top level class each time and just put in the little bits and pieces I need. Okay, so now at least my slides are gonna get prettier. We're still gonna be talking about testing though. So what I've done is I've gone through the app, and for each screen, I've pulled out a couple of concepts that we're gonna use. So let's start, this is the home screen. And we just have 3 buttons, so we have 2 if there's a camera. And so our actions are just like, either we're launching the UIImagery picker, or we're launching this web view with like some inspiration, which is just nice pictures that have been processed using the app. So it's just a web view, right? So the first thing we might want to test is that the right things happen when buttons are clicked on. So there's like 3 phases of testing buttons on iOS, and the first is that we don't do it. Okay, I did get a laugh there. Thank you, thank you. Thank you, the one person who laughed. And the second is that we expose this method that should be called, and then we write a test that says this method does what we want it to. And then the third way is that we get a button and we programmatically tap it and we see what happens. So let's look at option 1, which is that we make this selector and we test it, right? So this seems reasonable, you know, we've got decent coverage here. And there's two main problems with it. So the first is that we've exposed something just for testing. And this is not a big deal, right? This is why Java has visible for testing, yeah? And on Objective-C, we can just redeclare it in a category on our class, although I really like that even less. And the second thing, which I think is the biggest problem, is that we haven't actually verified that the action gets added to the button. And so the second option is that the selector gets added in the presenter in that ViewLoaded method I mentioned. And then we mock the home view controller and we return a real UI button for, say, the gallery, right? And then we call button send actions for control events, UI control event touch up inside. So that's how we tap the button, or we tell our code to tap the button. And then we verify what happens is what we expect to happen. So for example, the image picker is launched. So the downside to this is that it's a little bit more complicated, but the upside I find is like I haven't needed to expose any of the inner workings of my class. And what we're doing is we're verifying that when the button is tapped, the right thing happens. And isn't that what we want to know? Isn't that what's going to give us coverage and confidence in our tests? So the next thing here is like verifying that a VC gets pushed onto the stack. So, you know, we would call ViewController, navigationController, push ViewController animated. And so we're accessing this navigationController property, which is in the UI ViewController base class that all ViewControllers extend, right? So, you know, maybe we're doing this from the ViewController because we consider it to be view code, yeah? And so how can we test this? And the answer is partial mocks. So partial mocks are pretty cool, right? Because they allow us to only mock part of an object. And so when might this be useful? Well, when we've subclassed something that Apple's given to us, and we want to trust the things that Apple gave us, and we want to test the things that we put in there. Yeah? So here, what we can do is that we can mock the navigation controller. And we can create a partial mock of the view controller that returns a mock navigation controller, and then we can check what got pushed onto the stack. Okay, so our steps are, we create a mock navigation controller. We create a partial mock for the view controller we're testing. We stub to return the mock navigation controller. We set the expectations on the navigation controller, and then we call the method under test, and then our test passes and everyone's happy. Okay, image editing screen. Now things are going to get more exciting. So you can see here that now we have buttons on our navigation bar. So we can test those in a pretty similar way to how we test buttons on the screen. But I just want to point out that, like, because this is a screenshot taken on the simulator, there's no camera, right? And so when we do UI automation testing, we can only test what's on the simulator. So we can't test, say, a camera button. So this is why I think unit testing our UI code like that is really helpful, right? Because we've tested that the camera button behaves the same way as the gallery button, and then in our KIF test, we make sure that everything works. And if we have good unit tests and we have good KIF tests, even though our KIF tests haven't tested the camera button, we can be pretty confident it's going to be okay. So again, we've got these 3 buttons at the bottom, and the apply button here is a little bit more exciting than last time. But we'll go into that in a moment. So our navigation buttons, like for me, I set them in the view did load, and this is really just so they get separated out. So in my presenter, I have these properties of left navigation buttons and right navigation buttons. So my top level view controller class view did load looks like this. Calls the super, sets the left button, sets the right buttons, tells the presenter the view's loaded. So like I said, I create these buttons in the presenter because I want the target of the buttons to be in the presenter. But, you know, it doesn't really matter. The point is that it's isolated. So now we want to test that when the button is tapped, it does what we want it to. So we just get it out of the array returns and we call perform selector on it. And then once again, this is how we programmatically tap a UI bar button item. And then we can kind of verify things as we did before. So now we can talk about asynchronous code. So writing tests for asynchronous code is really exciting because, you know, if you get your test wrong, there's a good chance that another test will fail. So like it makes debugging extra fun or extra horrible depending on how much you enjoy debugging. So the apply button here, so what we do is to make the app feel faster, we like pre-process the image, and then the apply button is only enabled once that pre-processing is done. So this challenge arises because the pre-processing happens on the background thread. And so what we do is in the UI thread, we load the view, and then we switch to the background thread. In the background thread, we process the image, and then we come back to the UI thread, and we enable the apply button, right? So this sounds like really complicated, but actually what it means is that we never need to handle the apply button being pressed when the image is not already pre-processed. But it does definitely make our tests a little harder. That's okay, because Cate has a mechanism for handling asynchronous tests, and it's called an expectation. Who's used expectations? We're getting fewer and fewer of you, but like, you're still my people. So, you know, what we do is we create this thing, an expectation, and then we give it a time to timeout. So I put this at the end of my test. And so these are the two easy bits, right? Because now I've got to figure out when the expectation gets fulfilled, and that goes somewhere in the middle. So before we put that fulfill in, we're going to add those first two things, and our test's going to fail. And then we've got to find where to fulfill the expectation. So where would we put it? Well, in this case, we're wanting to wait for the apply button to be enabled. So we expect that the apply button becomes enabled, and then we use do. And so this is an OC mock thing, which means I expect this thing to happen. When it has happened, I want to do this other thing. So we can use that for all kinds of things, but I find it a really useful place to put my expectation fulfill. So I just want to be really clear because I found expectations super confusing when I started using them. The wait goes at the end of the test. Fulfilling it goes somewhere inside the test. Yeah? Okay. Last screen. So this is the last screen of the app, and you can see we've got these two images that are kind of like the inverse of each other. One shows the dominant color, and the other one hides it. And so you can see the dominant color here is red. This is at the Tower of London when they had the poppy exhibit on, and it was really very beautiful. So here we go to swipe between these two things, and this is actually a test that I didn't write. Like, don't get me wrong, I tried, and if anybody has any suggestions, I'll go back and try some more. But I couldn't figure out how to programmatically simulate a swipe gesture, and so I ended up testing it using KIF, right? And so I mentioned that here because, like, much as I think you can unit test almost everything, it is really almost everything, and not everything. And there are parts of the UI that are better covered by UI automation, and I decided that this was one of them. Okay. So now, this is the last example, so let's go even deeper. So show and hide's an image processing app, right? So it means it takes an image and it does some stuff to it, and then it produces these other two images, right? And so this was the part of the app that I really wanted to be able to develop against my tests. Firstly, because it is by far the most complicated part of it, and I really wanted to understand what was going on. And secondly, because I rewrote this part of the app several times before I could get it fast enough, and my tests were invaluable here. So just to see, like, just to kind of make it clear how far it came was in kind of my initial version that I first sent out to beta testers, it took like 5 to 10 seconds from pressing the apply button to get the two images at the end. No, you would only get one image, and it was quite scaled down. Right, and so now I've just been doing this like UI refresh, and the apply button is gone. And so as you change the slider, the images change, and that's how much faster it's got. And I attribute that to like, in part to having these tests that allow me to like develop against them and really work on optimizing it. So who's written tests involving images? Okay, like 6 of you? Cool. With just the numbers are going gradually down and down and down, yeah? So did you include your test images in the resource file? We have some nods? Okay. So I think this probably works fine for a lot of things, but what I wanted was images with certain properties so that I could say what they should be like at the end of this process, right? So to give you a sense of that, like this part of the app is actually only about 300 lines of code, but it has 22 tests, which is about 400 lines of test code, plus performance tests, which I put in a separate target because they each run 10 times and it makes things slow. But this is okay, right? Because we're programmers. So what do? We make things and we break things, including UIImages. So in addition to all my test code, I wrote these kind of helper functions that would draw the image into context. Like these are my simple ones. So like I could make an image with one color of a certain size. I could make an image with multiple colors, like a 2x2 4-color image, a 3x3 2-color image. These were really handy. And then harder, but like faster and much more flexible, creating a context, filling an array with RGBA values, and then calling CG bitmap context create image, right? What does that even mean, right? It means that I can say, I want an image with this width, this height, from this array of UI colors. Super useful. And so then kind of the inverse of that is to take an image and break it down into an array of UI colors. And then to compare two UI colors and see if they're the same. So like if their RGBA values are the same, I consider them to be the same color. So what does this even mean? So it means that I can create images with certain properties that match the tests I want to run, right? It means that I can compare the resulting images beyond size, because remember we want confidence and not just coverage, right? So what we can say is if two images have the same width, the same height, and they break down to an array where each UI color is the same in each array, we can say that those two images are the same, right? And it also means that I can create really enormous images for performance tests. So I'm not going to give you the code for this because it is not a nice thing for a Wednesday morning at 11 o'clock on the last day of a conference. It's all in GitHub. It's got an MIT license, so if you're doing anything with images, like you're welcome to use it and let me know if there's anything I can help you with. So let's come back to KIF, right? Because, you know, all this stuff with unit testing, does it replace UI automation testing? I'm just going to say no, right? Like, I really love KIF, you know, and I see these strategies as entirely complementary. I feel like my unit tests, they check the details, and the KIF tests, they check the big picture of the app, right? So the downside of KIF or UI automation tests in general is that they're slower to run, and they're much, much harder to test our corner cases on. But what they're great for is checking that each view loads, which, you know, we would think would be a given, but I have totally open apps. And like, you know, I go to some little used part of it and it crashes. I'm like, you need to write some UI automation tests, you know? And like I said before, testing things like carousels. They're also an opportunity to check the accessibility of our app. Like some people use KIF as an opportunity to break accessibility, and they make their accessibility label stuff that will make their tests easier. Don't do that. Sally's going to explain more about that maybe another time. But, you know, if you are going through and you're adding accessibility labels, if you add meaningful accessibility labels, you've gone a long way to making your app accessible to people who are visually impaired. So these are some of the most interesting challenges that on testing that I've encountered building Show and Hide, and, you know, aiming for like 90% plus test coverage. So like I said, I've got a workshop. I'll show you a link to that in a minute. But I'm going to finish my story now. You know, the day when I was told that we had to get our test coverage up to ship, you know, I learned how little I knew about testing and how the standards in the projects that I'd previously been working on just weren't good enough. They weren't good enough in general, and they really weren't good enough compared to the way that we write tests on the server side. So it was a real opportunity for me to start figuring out how to do these things, right? Because as I've covered here, like sometimes it requires a bit of thought and it isn't done often, but it's almost always possible. And so now I have the answer that I didn't when I was a junior developer. When that guy said we're moving too fast to write unit tests, and I thought, you're wrong. But I didn't have a good answer. And now what I would say is, how long do you want to move fast for? Because you know what, it totally is true that it is usually faster to ship today's code without unit tests. But it's not technical debt, right? It's an unhedged call option, and someday it's going to come to you. And so, you think about testing as an investment and it takes time, but if you can develop against your tests, you can start to get it back because it's so much faster. If you can be confident shipping a build in 30 minutes rather than 4 hours, you'll really start to see a difference. And I haven't really talked about performance tests much, but they're worth looking into if you want to kind of evaluate the performance of your app over time. But the biggest differences are the ones that are hardest to quantify. So, we always talk about testing about how if you find a bug early, it's much easier to fix it. But for me, the biggest benefit has been the structure and understanding I've got of my code when I've defaulted to trying to unit test everything. Thank you so much. I'm on the internet, as is everyone. This is my blog. You can find me on Twitter. My friend Chuki and I run a mailing list about public speaking in tech. And you can find information about my workshop here. I do charge for it, but if you're a student or underemployed, I'm super happy to give you a free copy, so just send me an email. And thank you so much. We have a little time for questions. Yeah. No, there's a sample code base and there's a PDF to go through. So I call it a workshop, but it's kind of like put aside an afternoon to learn to unit test, and at the end of it, you should be really off to a good start. Yeah.
You had mentioned that you had unit tests for one of your repackaging.
Yeah.
How did you try to make those tests so that they didn't all have to be
So I tested against the API. So the only time that I really had to refactor my test was I got the massive performance benefit when I switched to writing it in C. And so then, of course, I had to change all the interfaces to expect C arrays rather than NS object arrays. But other than that, it was really just testing how the array was changing a couple of things around calling it. So it wasn't a big refactoring. It was a very minor change. So the way I split it up, actually, and I didn't talk about this at all, is that I use static methods heavily. So if I want to test behavior, like something that's input in and output out, then I make that a static method. And then in my classes, I just tend to test more behavior. So for example, there's a thing called an image processor, which is kind of the state of where the image processing is. And then that just calls this other thing, which is just a collection of static methods. So that I've split those tests out. It's very easy to change anything. Oh, hi.
So I was wondering if you figured out a good way to test private methods.
That's kind of what the button thing is, right? So instead of making that method public, I can keep it private and I can test it by doing the action that causes it to be triggered. So in general, in any of my header files, there's normally a little section and there's methods that say these are exposed for testing purposes only. And my goal is to have as few or zero, but sometimes you need to do that. But then I think the best way to do it is to step back and consider, does it need to be private? Can it be in something else? Can you split it into another object? Is it triggered by an action? In which case, can you just test the action instead of the method? Hi.
Did you find that when you switched to exception or the asynchronous test,
yeah.
Did your tests slow down?
No, but I only use them when I need expectations. So there's not a huge number of expectation-based tests in there. And in general, that's about when you have your methods really small, say my expectation is testing that something gets called, it's not necessarily testing how that thing inside it works. So then I only need to test to have 1 or 2 tests that cover that scenario. Anybody else? Hi.
So when you said that you refactor the code and you wrote some tests, does that mean you don't do test-driven development?
It depends on what I'm writing. So when I'm writing something that is very clear, like you get this input, you get this output, there's a good chance I'll write tests first. But I think for UI testing, that's often not really possible anyway. And so I tend to write my tests as I write my code kind of concurrently, sometimes afterwards. Yeah.
Hi, I just wondered how often do you find yourself writing tests in your development cycle, or running them, sorry?
Constantly.
So is it like every time you make changes and you just quick run through all the tests?
Yeah.
Or I guess how long do they typically take to run?
Do you want to see them?
Yeah, sure.
Okay, let's go. So this is why I split my performance test out, because I noticed they were taking so much longer that it was stopping me from running them. But like my regular tests, done. And that's like so much faster than running your app. Anybody else? Okay, well, I cannot believe so many people showed up for a talk on testing on the last morning of a conference, right? So thank you so much for coming. Like, you can ping me anytime if you want to nerd out about these topics. And, I'm going to be here for the rest of the day, and I would love to connect with as many of you as possible. All right, thank you.